Hello friends, today we're gonna discuss about multi-thread survival in the present-day operating systems. Here are my name is Uday and here are our teammates Dheeraj, Akhil and Vivek. First, let's discuss the importance of operating systems and its priority. When going to the olden days, in somewhere in 1940s and 50s, the operating systems used to be the performance of operating systems used to be very low. This is because only one thread gets run at the same time, and hence there will be more time consumed to execute all the threads, and hence the performance decreases. But in the present operating systems, the concept of due to the concept of multi-threading, the operating systems have become more smarter, faster, and reliable. And to get deep into this, let's discuss first what is multi-threading. Multi-threading is nothing but the running more number of threads at the same time in a single program. And to efficiently uses multi-threading, cooperation is a key to the survival. Technically speaking, there should be strict synchronization between two threads running at the same time. Then coming to the producer consumer problem, this is a classical problem to which makes the synchronization between the threads. First, let's discuss what is producer consumer problem. In this producer consumer problem, the producer produces the items in the buffer till the buffer size is full, and then increments the counter. While the consumer consumes the produced items from the producer till the buffer is empty, and then decrements the counter. The problem arises when the producer and consumer tries to access the buffer at the same time. That is, producer and consumer wants to modify or change the data at the same time. And this condition is called race condition. That is both try to access the same memory at the same time. And this can be one of the method to eliminate this problem is called by using semaphores. We can also use this by doing mutex locks, but in our project we have implemented this by using semaphores. Uh, then coming to the implementation part, we have done in both environments, that is Linux and Windows. First, let us discuss deeply regarding implementation in Linux environment. We have created small video which describes the code, all the code and execution part. Let's play it. This is include stdio.h, and signal.h is standard library to include the signal all signal files such as signal interrupt handlers and everything. And unist.h is a standard Unix library to include all the Unix files. And pthread and semaphores are to include thread libraries and the semaphore standard libraries. Then we need a buffer, and in this program we have considered the buffer of size 10. We also have taken two functions or threads, that is one for increment, one is increment function and one is decrement function, namely for producer, and one for consumer, and the other one is signal interrupt, that is sig_int. Then coming to Okay, and here comes the declaration part. Here we are declaring two threads, that is the p thread increment thread and the decrement thread, and we are initializing it to 0. And the buffer size we have taken as 10. And coming to the main function, the first part we do in the main function is the semaphore initialization. Okay. And there are two semaphores, namely for one for producer and one for consumer. And here there are three parts, namely in each semaphore initialization. That is, one is that the address of data is passed into the semaphore, and the second one, 0, indicates 0 over here indicates this semaphore can be accessed only within the same function. If it is 1, it can be accessed throughout the program, that is outside the function as well. And this one indicates that we are giving the signal handler initially to 1 for the first semaphore and 0 for a second semaphore. Then it is a signal interrupt handler to handle the signals well. Then here we are creating the actual threads, that is pthread creates the first thread increment for the producer function, that is increment function, and the next thread is for decrement function. And coming to this pthread join, they're both pthread joins which checks for this actual completion of actual completion of increment function and decrement function. That is, once this threads get executed, then only this pthread functions and executes the program. But till now we are discussing the main program, and now the control jumps to increment function. In this increment function, we have initially declared the count variable to 1, and then here is a semaphore wait, which make this semaphore wait. Once it gets executed, the value of the count value goes to 0 and then enters the while loop. In this while loop, we are taking the whole data from the buffer, and that is, we are producing the data. And once the whole data gets produced, then it comes out of this loop, and then we need to give the signal handler to second semaphore. That is, before giving the signal handler, we need to make this thread 0. So this sempost data sem2 will is the signal statement to make active the second thread, and this thread initializer will go from the value 0 to 1. And then in the decrement function, the same way it works. Here in the sem wait, once this gets executed, the value of this count will go from 1 to 0, and then it comes to the while loop. Here it consumes all the data produced by the producer. Okay. So once the buffer is empty, that is, it consumes all the data. It comes out of while loop, and then in sempost data sem1 will give the signal handler to the first semaphore, and making inactive the present second semaphore. Then it then it executes out. The main point here is that only one semaphore should execute at a single point of time. So the key point here is that the key important statement here is that the sem post data sem1 and data sem2. So we need to be cautious in writing this. Then coming to signal interrupt, once you have successfully done this producer and consumer producing and consuming the data from the buffer, then we need to cancel the threads and destroy the semaphores. For this we use pthread cancel and pthread cancel function, one for increment function and one for decrement function. Semaphore destroy will destroy the semaphores completely. And coming to the execution part, cd changes the directory to our main directory, and then we are compiling here. This is the command for compiling the program in Linux. Now you can see the output. Okay, so it is producing and consuming continuously. So we can here see this is a comparison we have done. This is the one we got without implementing the semaphores. You can clearly see here there is no synchronization between the threads. That is, consuming data from the buffer is taking erroneously. That is, it is taking the 0 continuously, and then it is coming for 6, 7, 8. It is random values. Okay, now let us see the implementation using semaphores. That is, previously we have done the implementation. This is the output for that. Here we can see the proper synchronization between the threads. If we look into it, first initially producer is producing the data. That is, it takes all the values from 1 to 9. Here we have, in this program, we have taken the buffer size of 10, and it takes the values from 1 to 9. And then once the producer buffer is full, then consumer starts consuming. That is, again it prints the data like 1 to 9. So there is proper synchronization between both the threads. and all this implementation we have done is in the Linux part, and we can do the similar implementation in Windows as well, but the API is different for both Linux and Windows. And if we give a glance to this Windows API, the similar function to this unistd.h, that is to include all the standard Unix library uses in Windows, is windows.h. And similarly to take the threads, it is a handle function. And for cancel the threads and destroy the semaphores, it is pthread cancel in Linux, whereas close handle in Windows, and close handle for semaphore in Windows. Okay, and the problem for this without semaphores using is that the data gets corrupted, and also illegal memory access will be done. So with semaphores, the both problems of that would be avoided, and hence the performance of the operating system would be increased. This is the overall summary. We have done implementation. We have done the implementation parts in both Linux and Windows. Before closing, we'll quickly look into the implementation part in Windows. We have written a code, and we are running it in Visual Studio. Let us quickly run it. Let me quickly run it. See, it is continuously producing and consuming the data, and to interrupt this, we need to use Control C as interrupt in Windows. So I've done it. Let's break this exception, and now we can see this. Here also we can see the synchronization between both the threads. Initially it is the producer is putting the data, so it is taking the values from 1 to 9, and then consumer starts consuming, that is 1 to 9. So here also there is proper synchronization between threads, and both threads cannot run at the same time. So this is the overall overview of what we have done. Thank you.